Hello everyone, welcome back to the video of p5 coding. So in this video, we're going to talk about loops once again. So this is going to be the second part of my loops tutorials. And in this video, we're going to look at some examples where loops can come into use. So in order to understand this video, it will be very highly advantageous for you if you watch my previous video about loops. So the link is given in the description. You could watch that. So I'm going to talk about 5 to 6 tasks or examples in this video so that we can clear our complete concept about loop. So without any delay, let's get started. So this is our first task to find the sum of all the multiples of 5 till 150. So how could we approach this? So let's think about this. So first of all, I'm going to need a variable called sum, right? Obviously, so I'm going to need a variable called sum, and this variable is going to start at 0 because initially I have no numbers, so it is starting at 0. And now I will have and I do not need the function setup right here because I'm working with basic JavaScript. But soon when we will be working about animating stuff, we will see graphics, using graphics with loops. Then we will need the function setup and function draw. But for now, I can directly write the code. So I will need to have a loop and I need to find where to start. So where to start, when to end. So these are the things I will need. So I'm going to start, let's say, what is the first multiple of 5? So the first multiple of 5 is 5 itself. So I'm going to start at 5 and I will end at 151, I guess. Yeah, because I want till 150 because 150 should be counted. So I will have to end at 151. Yes. And then I can just simply increase my counter or my operator variable. The operator can variable can go up just by 5. So it will increase by 5 each time. So these are the things I'm going to need. So let's have a loop. I'm going to use the for loop for this. So for, if you do not know the syntax, as I said, you need to watch the previous video. I've covered all this in detail. So for let I, it is starting at 5 until I is less than 151 and I plus equals 5. I need to open and close my braces, and then I'm going to say sum plus equals I. So I think this is just it. Sum plus equals I, and then at the end I just want to say console.log the sum. So let's just recheck the code, double check it. Sum is equal to 0. I is starting at 5. So the first position, my sum is going to increase by 5. The I is increasing by 5 again. So next it is going to increment by 10. That's fine. I'm going to do this till 151. So let's run this. Okay, so we are getting 2325. I hope this is correct. So let's try to do this for a smaller number just for debugging. So let's do it at 51. I am getting 275. Let's check it with the help of the calculator. Okay, so I got 255 plus 50, and that is equal to 275. And I have got 275 as well. So let me change this back to 151. So hopefully this answer is correct. So our first task is successfully accomplished. Okay, so our next task is to find the factorial of 10. So what do you mean by factorial? So factorial of a number means that you need to multiply all the numbers from that number till the number. So factorial of 10, let me explain in simple words. So factorial of 10 will be to multiply all the numbers from 1 to 10. If we were asked factorial of 4, we would do 4 times 3 times 2 times 1, that is 24. So factorial of 10 will be 10 times 9 times 8 times 7 times 6 times 5 times 4 and up till 1. So this is the factorial of 10. So here I will take an approach which is similar to the previous one. So I will have a variable which is called factorial, right? So it starts at 1 because I do not want a product of numbers to start at 0, because each time I multiply anything, it is going to remain at 0. So I want it to start at 1. So now let I is equals that number, and let's say that I will have a variable for the number as well, so that is 10. So till I is equal to the number, so I'm starting at the number, I am ending at 1, or should I say it is not at 1, because I want the 1 to be calculated as well. So I want to end at 0, and the operator variable is going to be -1. Yes. So let's see. So I have given I as num. So where to end? That means when I is greater than 0, only then do I want to do this thing. And I want to decrease the I by minus and minus. And then just say factorial times of I. And then console.log factorial. Let's see what we've got in the console. Okay, we've got a huge number, which is 362,800. Is this right? Okay, let's do it for a smaller number. Let's do it for 4 first. Okay, we should get 24. Yes. Let's do it for 5. We should get 120. Yes. So I do not want to calculate this. This is a huge number, but I think this is right. You could check that if you want, but I think this is right. So we have successfully done our second task as well. So the next task will be to check if a given number is prime. So let me clear this code a bit for you. Let me remove this for loop. Let me remove this. Let me just clear this up. So yeah, so my number is going to be a variable. I'm going to check if the number is prime or not. Okay, so let's say our number is a prime number. I'm going to check for 17. Then where should we start? Now I will need a for loop for this. So where should we start? Now let's see. So what I want to do for this purpose is to check that all the numbers which are less than 17 are divisible by I or not. So I'm going to check that. So I want it to start at 2. Now why do I want it to start at 2? Because any number is always divisible by 1. That's perfect. And any number which is when divided by 0 will give us infinity. So I do not want 0 and 1 to come in the cause. And it should end when the counter variable reaches a number. So I do not want to check any number which is more than 17. And I do not want to check 17 as well, because we know that any number will always be divisible by 1 and the number itself. So I do not want those two numbers to come into our calculation. And then the operator variable is going to just increase by 1. Let's write the for loop. This is going to be exciting. So for let I equals 2, I is less than num, all fine, and I plus plus. Okay, so what do I want to do here? I want to check if this number modulus that means when I divide the number by my I, it is equals 0 or not. That means it is divisible or not. If yes, I want to break out of the loop. I do not want to check anymore. I want to break out of the loop, and let's say I want a boolean variable that prime, which is initially false, and I want to set prime to true, and then just break out. No. Let prime be true. No, sorry. Prime is true. Here prime will be set to false, and I will break out of the loop. I do not want to calculate more. So if you do not know what the break operator is, I have not explained it in my videos. So break is a kind of command which is used to break out, to stop executing a specific loop. So break. Else, so this is done. So I want to check for every I, if any time prime is equals false, just set prime to false, then break. Then come out of the loop. Then I want another if statement that if prime is equals true. If prime is equals to, just console.log prime. Just say that prime or okay, just wait. Yeah, else just console.log not prime. Okay. So let's check. What is the chance this code is going to work? Prime, okay. 17 is prime. Now let's check it for more numbers to be sure that it is working. If I check for 17, prime. If I check it for 8, it is not prime. If I check it for 2, 12, it is should be not prime. Now let's check it for a complex number like 91. The 91 is divisible by 3. Let's check it for 65. Not prime. But if I write 67, whoa. If I write 67, it is prime. So this is working. I hope this is working. You'll check for more numbers to ensure this is working, but I'm sure that this particular code is working. Now you can see what complex possibilities are coming to us once we have learned to use loops. I will do one last example with text-based programming, and then we are to head to straightforward to graphic-based programming. Okay, so our next task is going to be printing the vowels of a given word in number. So I will have to remove all this. Printing the vowels of a given word in order. So let's start with the word. So this is going to be character-based program. If you do not know about this, you will get an idea about that as well. So let word equals, okay, let word equals programming. Let's start with this. Let the word be programming. So I want to print all the vowels of this word in order. That means O, then A, then I. So O, A, I should be my order. So let this be another character based thing, which is initially nothing, just blank. So now I will have to run a loop for, so let's see. So for let I, which is starting at 0, and until I is less than word dot length. So word dot length means I want to check how many letters. So if I, just for making you understand, so just let's say console dot log word dot length. So what is this supposed to give me? So let's simplify the word. Let's make it program. If I run this, I'm going to get 7. So the word length, the letters of the word are program. So this is the length of the word. So I'm getting 7. So if I now loop from let I equals 0, I is less than word dot length. I'm checking each letter of my word now, right? I is going up by 1. Then I will have to say, now let's say I want to check each letter one by one and then add it to my order. So let my current position be word, wait. So where we are, so I will have to find, whoops, so I will have to find the current position of the current letter. So way to access a particular letter of a word is write word, that is my variable, dot charAt. So this is a JavaScript function. So this is my JavaScript function. The charAt means the find the specific character letter of a word. So if I say charAt I, so if, okay, for understanding, let's say print, okay, this is a p5 function, no, console.log word dot charAt 1. So my first letter of the word is going to be printed if I use the charAt function. So let's implement this. It is okay, it is actually R. Okay, I have set a 0, sorry, yes. So my 0 will be P, so my 1 will be R. So like this, if I will access each letter of my word. So I want the I index letter of my word charAt I. Then I want to check if the current is A or current equals B. Oh, not B. No. What I'm doing? Yeah, it is equals. So it is current equals E, or copy this entire thing once, just for my, okay, and then add this again. Change this to I. Change this to O, not capital, and or if current. Now you could use arrays for this if you have an idea about arrays, but I'm going to use this simple if statement, which is very long. So if this is satisfied, then order plus equals current. That means to the order string add this current string. Okay, and then at the end when my loop is done, just console.log the order. So what am I doing? I'm having a word which is I'm going to change to programming. Okay, programming, let the order be empty string. I'm starting at an empty string. So for all the lengths of this word, that current is what current I, and then I'm checking this entire if statement to find if that current word is a vowel or not, and then I'm adding this current to my order, and at the end I am console logging my orders. What is the chance that this is going to work? Hey, there we go. We've got O, A, and I. So is this the order? O, A, and I. This is fine. Let's have another complex word, which is alphabetical. Okay, alphabetical thing. Okay, so this word has got A, A. This is working. So we have talked about 4 examples of text-based programming using for loops, and now in this video we're going to cover not more, just 2 examples of how you could apply this loop uh, idea in graphics using p5.js library. I have got the p5.js library inserted here. So let's have a simple example first. Okay, so this is our next task, everybody, to divide a P5 canvas into 20 parts. So we will need the function setup finally after a long time. So the function setup comes here. We create a canvas of 500 and not no 600 and 600, a bigger canvas. Then I want to divide the canvas into 20 parts using lines. So let numbers, I'm going to store this 20 as a variable. Let number equals 20. Then let's say I want the width, each width of the part be w equals width divided by this number. Okay, and then I want to run a for loop again. The for loop is going to start now. Let's see how to start. My for loop is going to start at my x coordinate 0. I'm going to do it in the x side. In the x coordinate 0, it is going to end at width, and each time it is going to increase by w. That is the width of each individual part. So let's do this. For let I equals 0, I is less than width, and I plus equals w, I equals w. So I want to draw a line. Okay, and let me set the background here. Okay, let's say the background to 200. So I want a line of stroke weight 2, stroke of 0, and I want to draw a line. I want to draw a line. Whoops. I want to draw a line at that I. No. This will be W. It is starting at W. So I want to draw a line from I, and my Y coordinates are going to be just 0 to I to height. That means I'm drawing a line from x equals 0, x equals I, and y equals 0, that is the top point, to I and height. I'm drawing this line, and let's see if it works. Okay, W is not defined, Y is not defined. So, okay, I have not used W here. I deleted the W line. Okay, so let W equals to weight divided by number. Okay, there we go. I just remove this console right here, and there we go. We've got it as this much. Wait. Oh, I have an inner width. Why? This should be width. Yes. Now you can see I've got in 20 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So my P5 canvas has got divided into 20 parts using this specific code. Now, let's say the number is not a fixed variable, a number is a random variable. So let number be a random number between 5 to 25, and then I'm dividing the width by this. Then let's see what we get. So if I refresh this, you see each time we get a different thickness and different numbers. So you can see you get different thickness of divisions, but all these are symmetric, and this has been done using the for loop. So this is the last task I'm going to do in this video. So you want to place 20 points randomly in my canvas. So let's have the function setup. There we are. In the function setup, let's create a canvas of 600 and 600. Let's set the background to be 0. Let's the background be 0, and then let's calculate an arbitrary let's have a loop. So for let I equals 0, I is less than 200. I think you must be familiar with this by now, but with this, and then let x equals a random number between 0 and width. Let y be a random number between 0 and height, and then draw a point, and then x and y. Set the stroke to 255, by the way. Set the stroke to 255, and if I run this, you can see that I've got 20 random points generated on my canvas. Let's set a stroke weight to 2 or to 3, I think. Yeah. And now you can see I've got this 200 points generated random. It looks like a space. We're looking at a large number of stars right there. So you can see, you can do this every time a random gets generated. Now, you could try to use the vertex function now and just write begin shape, and so I'm using a custom shape here, and then you could try to have a shape with these number of variables. This is going to give you definitely something crazy, because randomly points are getting generated and they are getting connected, so it does not make any sense. You might try to make it more interesting by having no fill right here. So you can see that it is like a mesh of points all connected randomly. You could decrease the number of points to let's say 50. You could then see what kind of arbitrary squiggly lines you can get. Now no, just a second. So if I am doing this no fill, let's set it back to point for now. Yes, so you can see I've got, okay, let's just set it back to 20 to 100, let's say. So now there is a way, if I say that there is a way by which you can draw an outline, like an outline polygon shape with respect to all these points. That's actually called the convex Hall algorithm. So I will cover this in some of my next videos very soon. It is going to come. Now, if you want more complex visualizations, you could look at the times table cardioid, which I had made in one of my previous videos. So I think that's it for this video. So thanks for watching and goodbye.